Okay, so it says here, pebble is projected vertically upwards with speed of 7 meters per second. Okay. From the top of a cliff, it hits the ground at the bottom of the cliff 4 seconds later. So it comes back down to the bottom of the cliff, so it comes down here when t is equal to 4. Okay. Calculate the time for the pebble to reach its maximum height. So that's part A. Alright, now, first thing you need to note, because it's projected vertically upwards, we're going to take upwards as positive throughout the whole question, right? Upwards positive here, because it's projected upwards. Now we know acceleration acts downwards, okay, due to gravity, yeah? So because it's acting downwards, opposing the positive direction, we've got to write acceleration to be minus 9.8. We know u then is equal to 7, okay? And we want the time it takes for it to reach max height. Now, if you think about it, what's true when it gets to max height? Well, if you throw it up, maximum height we want is literally where it stops rising, yeah? So it goes upwards and maybe it reaches its peak here, okay? And then it starts to fall. Now, as it gets to its peak, it starts to slow down, doesn't it? And when it actually hits its peak, it has literally it hasn't got enough energy to keep going. Okay, so it'll fall then. So we could say at max height, the velocity is equal to 0. Okay, so using v equals u plus at, velocity is 0. U is 7, A is 9.8, and T there. Okay, so I'll plug that in. All you've got to do then to get the time is, well, we take the 7 over, so it becomes minus 7, and then divide by minus 9.8. Okay, so if I do that on my calculator, it comes out to be 5 over 7. Okay, I mean, perhaps leave it like that, because as a decimal it's not so nice. So 5 over 7 seconds. Okay, part B then says determine the height of the cliff. Okay, so we want to work out what h is, don't we? Okay, the height of that cliff there. Alright, so let's think about what we know. Well, we know, again, right, A is minus 9.8. Now, to get the height of the cliff, we've got to use this time, haven't we? Time equals 4. Okay, it takes 4 seconds for it to land down here. So when it hits its peak, when it hits its max, it then falls down, and it takes 4 seconds for it to get to the bottom of the cliff. Now, as I said, because we take it upwards as positive, right, the direction it was projected in was upwards, so we take it upwards as positive, acceleration opposes that, so it's minus 9.8, and it stays minus 9.8 throughout the whole question. So we want it when t is 4, okay? We want s, basically, that's what we want, don't we? Okay, but we also know u, don't we? U to be 7, and I think I've got enough information there, because what I can do now is, using s equals ut plus half at squared, so s will equal to 7 times 4, okay, u times t plus half a, which is minus 9.8, times t squared, which is 4 squared. So on my calculator, comes out to be minus 50.4 meters. Okay, so quite straightforward, substituting in. The question you need to ask yourself is, well, why is it in minus? Now think about it, going back to the diagram. Our starting position is where our origin is, if you like. So in the sense that s is 0 at the origin, yeah? The displacement is 0 at the origin, at the starting position. It goes up to start with, so we take it upwards as positive. But then when it hits the max and then falls, it goes underneath our origin then, doesn't it? If you think about it. Okay, so we've got to think of this as an axis system. Up here is positive values, down here is negative values. Okay, so it passes our origin and it keeps falling. So that's why it's minus. So it's at a height of minus 50.4. But of course, when we ask for the height of the cliff, we can literally say, look, the cliff height there is 50.4. That's how high that cliff is. Came out as minus based on how we set up our equations.